Hello, Chemistry 10HH students. This is Mrs. Altman. We are on video number 18, Atoms, Molecules, and Ions, Part 5. Here are our objectives for today's video. Pause here. So we're now going to be still talking about our type 1s and type 2s, but we're going to incorporate something called polyatomic ions. So these are just groups of covalently bonded atoms with a net charge. I'm going to quickly just sketch what one of these would look like. It's not something you really need to know how to do, but I just want you to have a little context for what we're doing. And if what I'm doing right now just seems a little foreign to you, that's fine. We're gonna look at this later in the year anyway. So I've got a group of covalently bonded atoms, but the net charge is not, it's not zero. So this is carbonate ion. This is CO3 2 minus. So the 3 comes from the fact that there's 3 oxygen atoms in there, and then the 2 minus comes from the fact that the overall charge is -2. For the HH class, I don't make you memorize the polyatomic ions. That's something that comes up in AP, but you'll have so much practice with them by that point in time that it's not typically something that's difficult for students to do. Pause here. So when something contains a polyatomic ion, it must be, for right now, type 1 or type 2. It could also be an acid, but we haven't learned about those yet. And then we follow the same naming conventions, except you don't need to change the suffix of a polyatomic ion. So if I haven't already given you a polyatomic ion sheet in person, I'm sure I've posted it to Google Classroom. So for example, the first one at the top of the sheet says phosphate. So you don't need to change that to anything. The suffix was already changed when it was put onto the polyatomic ion sheet. Pause here. Oh, that should say Na3PO4. So please change that to Na3PO4. Okay. So this is type 1. So and you don't necessarily have to write that. I'm just writing it so you see where I got everything from. So it is sodium, and then I find PO4 in my polyatomic ion sheet. It says phosphate, so sodium phosphate. For the second one, FeCN2, I'm going to actually write this one out. I'm going to do it kind of similarly to how we did before. So I have one iron. I don't know what its charge is. I'm going to call it X. I go and I find Cn on my polyatomic ion sheet. I see it has a charge of -1. So 1 times X plus 2 times -1 is equal to 0. X is equal to +2. So I have iron 2 cyanide. And then for NH4Cl, so there are 2 positively charged polyatomic ions, NH4 plus and H3O plus. So if anything starts with one of those, you know it's type 1. So this is ammonium, because I find NH4 on the sheet and it's ammonium, and then chloride. Let's take a look at the next one. Pause here and take a moment to try this. I'll write out the first couple ones of these and then go a little faster. So I've got calcium with a 2+ charge. I find hydroxide on my polyatomic ion sheet. Its charge is -1. Crisscross applesauce, but I want that 2 not just to apply to the hydrogen, that's a 1, but also the oxygen. So I have to do Ca parentheses OH and then a 2 on the outside. So anytime you are bringing a number outside of a polyatomic ion that isn't 1, you have to put it in parentheses. So my answer ends up being CaOH2. And then let's take a look at manganese 4 nitrate. So Mn4+. I find nitrate on my polyatomic ion sheet, NO3 minus. Crisscross applesauce, I bring down this 4. That 3 has to stay inside of the parentheses. So Mn parentheses NO3 close parentheses 4. Magnesium carbonate. So I have Mg, which is standard charge of 2 plus. I find carbonate on the polyatomic ion sheet, CO3 2 minus. So I crisscross applesauce 2 and 2, which some of you are probably realizing we're just going to nix because they're simplifying it. We don't need parentheses here because I'm not bringing anything on the outside. It's just MgCO3. We have aluminum dichromate, so aluminum with a 3 plus. I have to find dichromate on this sheet. It is Cr2O7 with a 2 minus charge. Crisscross applesauce. So I'll go ahead and just type that one for the sake of time. And then we have iron 3 sulfate. So iron with a 3 plus charge, sulfate with a minus 2 charge. So Fe2 to 4. That is all for tonight's video. Thank you so much for watching and have a great night.